So under probability distribution, so what is meant by a random variable? Random variable is a function which assigns each element of sample space to a real number, usually denoted by the symbol random variable is capital X, so which is a function from sample space to a set of real numbers. So domain of the random variable is sample space and range is a subset of real numbers. So let us consider an example. Two coins are tossed at a time and capital X is a random variable which denotes number of heads occur. So the sample space contains the four elements HH, HT, TH and TT. So the number of heads corresponding to the first element is 2, second element is 1, third element is also 1, fourth element will be 0 because here we are counting the number of heads. So the range of the random variable will be 0, 1, 2. Next, another example. Two dice are thrown at a time. X is a random variable denotes sum of numbers appeared on two dice. So the range of the random variable becomes 2, 3, 4, 5 and so on up to 12. So types of random variables. There are two types of random variables. One is discrete random variable and another is continuous random variable. Now, what is meant by a discrete random variable is a random variable which takes specific values is called a discrete random variable. Example, number of children in a family. Another example is number of cars sold in a company per month. Another example, number of times a coin tossed until head occurs. Next, continuous random variable. A random variable which takes all possible values in an interval is called continuous random variable. One example is height of a person in centimeters. Another example is life of an electric bulb in hours. Because these values can be fractions, so that's why it will be an interval which takes all possible values. Probability mass function. Let capital X be a discrete random variable whose range is capital X equal to x1, x2, x3 and so on xn defined on a sample space S. A function which assigns each element xi belongs to the random variable x, a real number pi, that is p of x equal to xi equal to pi, where I equal to 1 to n, is called probability mass function denoted by PMF if it satisfies the conditions. First condition is each pi must be greater than or equal to 0. That is p of pi greater than or equal to 0 where I equal to 1 to n, and sum of all the values must be equal to 1. That is sigma I equal to 1 to n, pi must be equal to 1. That is sigma p probability of x equal to xi I equal to 1 to n equal to 1. Because the sum is 1 and each is greater than or equal to 0. So this function itself becomes a probability mass function. So example is find the probability mass function of the random variable x, denotes the number of tails occur in tossing 3 coins at a time. So because the 3 coins are tossed at a time, the sample space contains the 8 elements and the random variable takes the values 0, 1, 2, 3. So probability of x equal to 0. That is a random variable denotes the number of tails. So the number of tails must be equal to 0. So it will be 1 by 8. Probability of x equal to 1. So the number of tails must be 1. So 3 upon 8. Probability of x equal to 2. 3 by 8. Probability of x equal to 3. 1 by 8. And when you add all this, it must be 1. Probability distribution. A tabular form which shows values of discrete random variable with the corresponding probabilities is called probability distribution. Now, so if we consider the previous example, 3 coins tossed at a time. So the number of tails occur, the random variable corresponds to 0, 1, 2, 3, and the corresponding probabilities are 1 by 8, 3 by 8, 3 by 8, and 1 by 8. Next, cumulative distribution function. Let capital X be a discrete random variable whose range is x1, x2, x3, and so on xn with the corresponding probabilities p1, p2, p3, and so on pn. The cumulative distribution function is denoted by capital F of x, and defined as capital F of x equal to probability of capital X less than or equal to small x. That is f of xi equal to probability of capital X less than or equal to xi, which is equal to p1 plus p2 plus p3 and so on pi, where I equal to 1, 2, 3 and so on n. Consider an example. Two dice are thrown at a time. Express the cumulative distribution function of the random variable x, which denotes the sum of numbers occurred on the dice. Now, here the random variable takes the values 2, 3, 4, 5, and so on up to 12. So the corresponding probabilities will become 1 by 36, 2 by 36, 3 by 36, 4 by 36, 5 by 36, 6 by 36, and again 5 by 36, 4 by 36, 3 by 36, 2 by 36, and 1 by 36. Now, cumulative distribution function, capital F of x. For the value of the random variable 2, it is 1 by 36. Now, when x equal to 3, you have to add. So 1 by 36 plus 2 by 36 becomes 3 by 36. For the random variable x equal to 4, that is capital F of 4, you have to add up to 4. So 1 by 36 plus 2 by 36 plus 3 by 36 is 6 by 36 and so on. Suppose for the same problem, if it is asked to find probability of 3 less than or equal to capital X less than or equal to 6. That means what the probability of the random variable which takes the values from 3 to 6, which will be same as probability of x equal to 3 plus probability of x equal to 4 plus probability of x equal to 5 plus probability of x equal to 6. We have to add all these probabilities. How much it will be?
14 by 36.
3, 4, 5, 6. No.
14 by 36.
14 by 36. Correct. Which is same as 7 by 8. Suppose instead of this, if it is asked probability of x greater than or equal to 10, given that x equal to 9. So probability of x greater than or equal to 10, given that x equal to 9. Is it exists?
Now 8, 9 greater than equal to 2.
Sir, 0, no?
Will it exist? Because as per the definition of conditional probability definition, probability of A given B will be what? Probability of A intersection B upon what? Probability of B. Now here probability of A intersection B. That means is there any value of x which is greater than or equal to 10 intersection with x equal to 9? No. So it will be what? 0. Can you say 0 or does not exist?
0.
0. Okay, let us take another one. Probability of x greater than or equal to 6, given that x greater than or equal to 8. What will be this probability? So probability of x greater than or equal to 10, given that x equal to 9 is 0. Probability of x greater than or equal to 6, given x greater than or equal to 8 is 1. Probability of x less than or equal to 3, given x greater than or equal to 2 is 3 by 36. mean, variance, and standard deviation of a discrete random variable. Let us take capital X is a discrete random variable whose range is x1, x2, x3, and so on xn, which is a corresponding probability mass function pi, where I equal to 1 to n. So the mean of a random variable is denoted by capital X bar, or another way of expressing is expectation of the random variable x, that is written as E of x, which is sum of the products of random variable values with the corresponding probabilities, that is sigma equal to 1 to n xi into pi. Variance of the random variable x is written as var of x, or another notation is sigma square, which is defined as sigma equal to 1 to n xi minus x bar whole square into pi. If you expand and simplify, you can derive it as sigma equal to 1 to n xi square into pi minus x bar whole square, where x bar is sigma equal to 1 to n xi into pi. So in terms of expectation notation, it can be written as E of x square minus E of x whole square. Next, standard deviation of the random variable x, which is the square root of variance, that is square root of sigma equal to 1 to n xi minus x bar whole square into pi. So the simplified form can be derived so by expansion xi minus x bar whole square, xi square pi plus x bar square pi minus 2 xi x bar into pi. Apply sigma to each of the term and then simplify. So variance second formula in the simplified form is sigma xi square pi minus x bar whole square.